Okay, you're wondering what this is and why I'm all on the ground, you're all the way up there, but that's just, you gotta be able to see this thing. But, what is it? It's just a string. One string. But, if you want to be fancy, you get to call it a monochord. Monochord, that's right, it goes back 2,500 years. Supposedly, Pythagoras invented this instrument to teach the musical intervals. It's really uncertain whether it was like... So, anyway, Pythagoras is at least reputed to have sort of discovered these fundamental relations. He also believed that these are the same sorts of principles that govern the structure of the universe and the way the body works, the way the soul connects to the body. But right now, just want to show you how this monochord works. I learned just how to make this thing from a YouTube video by Tal Katsir. She just has this super cool video that just tells you how to do this right away. So yeah, it did not take me that long to make this instrument. I mean, it took embarrassingly long. It didn't take that long. It's still not a perfect thing, because let me show you. It's one string, right? And then if you just play the string by itself, you can't really hear it that well. But an octave below. But that's okay, because that's not the main thing that we're using this for. What we're using it for is to teach the ratios and proportions of things. So, what I have, and no, you probably can't see the lines on here, but I have, this is 36 inches from here to here. And so I drew out lines for each of the 36 of the inches. And then I worked in ratios. 36 is a number that can be divided by a whole bunch of different things. 1 times 36, 2. Yeah, it has a lot of divisors. Here I've divided the string just exactly in half. So 18 inches over here, 18 over here. This thing is right in the middle. It's not exactly perfect, but let's hear what it sounds like. I know at this point you're thinking like, that's not very interesting. Why do you need one string to play two notes that are the same note? But anyway, okay, it's called the unison. And we have the whole string, we've divided it exactly in half, but we're not comparing the sound of that whole string to the half string. We're actually comparing the sound of half of the string to half of the string. We just think of the length of this, and then this is exactly the same as this. So it's a ratio of 1 to 1. And so that makes sense that it's going to be exactly the same pitch. But let's check out some other ratios. I'm going to now divide this string into 3 parts. So my 1/3 point is here, and my 2/3 point is here. These are reciprocal operations, so I'm just going to move the bridge over here. And I could do exactly the same thing if I did it over there, but I'm not putting it there. Okay, so now what I have is 1/3 of the string and 2/3 of the string. And so the ratio I'm getting is actually 1 to 2. So this length, if we did it twice, it would look like that. Okay, so the ratio of 1 to 2, or if you do low to high, 2 to 1, 2 to 1. It produces an octave. So far, up until now, we just had the 1 to 1. That's a unison. That's not terribly interesting. No offense to the unison. Unisons are good. I'm working on a book. Are you curious about other ratios? We've divided the string into 3, and we've got 2 parts to 1 part. It goes Let's divide it into 4, and then compare 1 to 3. Yeah, 1 part to 3 parts. We divide it into 4. It's gonna be 9 inches each, right? Because 36. So quarter here, my half point here, and then the 3/4 point here. So we've already done the half point, and I'm just gonna put this over at 1/4 of the string. So we get to compare now the sound of 3 parts of the string, 3/4 to 1/4. So it's 3 to 1. Let me tune it. Now, if we divide the string into 5 parts, which is a little bit hard with the math because we've got 36 inches, but don't worry, I worked it out. 5 parts, we can check out the interval of 2 to 3. And they're actually similar. 1 to 3 is a 12th, perfect 12th, otherwise known as a perfect 5th plus an octave. If we do 2 to 3, we're going to get the interval of the perfect 5th. So I've divided the string now into 5 parts. There's 1, 2, you can't really see them, but it goes like 2, 3, 4, 5. Okay, so 1, 2 parts over here, and then 1, 2, 3. So we're really comparing, I know it's kind of tricky. So we'll do 3 to 2, we always do low string first and lowest sound first. That's a perfect 5th, and so the ratio of 3 to 2 produces a perfect 5th. And you just remember before that when we had 3 to 1, we had an octave plus a perfect 5th. So far we've divided the string into 2 parts, and we got a 1 to 1 ratio, and that's just a unison. Then we divided it into 3 parts, we got a 2 to 1 ratio, and that was the octave. Now we divided it into 4 parts, and we got a 3 to 1 ratio that was an octave plus a perfect 5th. When we divide it into 5 parts, we get a 2 to 3 ratio, right? 2 plus 3 equals 5. And we now get a perfect 5th. We'd actually have to divide it into 7 parts in order to get the sound of the perfect 4th, because we need a 3 plus 4 thing. Let me show you one more division, because I have 36 inches, so I can divide that easily into 9 parts. Let's just check out all the possible divisions of 9 parts. It could be 1 and 8, 2 and 7, 3 and 6, which we've already had as 1 and 2, 4 and 5. Okay, and 4 and 5 is a really interesting one. Ready to divide the string into 9 parts: 1 ninth, 2 ninths, 3 ninths, 4 ninths, 5 ninths, 6 ninths, 7 ninths, 8 ninths, 9 ninths. The 4 ninths point, I get 4 parts over here, 4 ninths of the string, and then 5 ninths over here. So it's 4 parts to 5 parts. What do you think that ratio is going to be? La, dum. It's a major third. So, I'm going to leave it there for now. I've been reading about the monochord for a long time, and I don't know, I just thought I understood it, and then I started writing about it recently, and I just kept having to look things up that didn't quite make sense the way I thought they did, and then it just is much more kind of confusing than you might think. And even understanding the harmonic series, which I have completely memorized. But anyway, doing this procedure, which is how music was done, how it was measured, how intervals were thought of, from at least 500 BC with Pythagoras to basically about 1500 AD, so 2,000 years. Very interesting exercise for the mind. I guarantee you that you'll learn stuff that you thought you knew that you didn't. What did I want to say about that? And then, last thing. But the thing is, it's a very simple instrument, right? And so it's not completely impossible for dogs to do it too. Like, you obviously have to train them. The math is difficult. See?